Okay, so let's start some problems, but before all of that, I need you to pause the video and do 5 jumping jacks. So that tells me in the classroom that you are at this point of the lesson. And no, I am not kidding. So go ahead and pause the video. Okay, now that you've done 5 jumping jacks, your brain is ready. Let's start. So you have a graph of a function f shown above. Which of the following is the graph of the derivative? So I know many people dislike this, but we can do it. We have to do it piece by piece. Let's look at the graph. The first part is increasing. So that means the derivative is positive, which is above the x-axis. Then we have a maximum, which is a 0, so it crosses the x-axis. Then we are decreasing, meaning the derivative is negative, which is below. Then we have a 0 here. Then we have an increasing, which is positive, meaning above. Okay, so we're going to look through every single picture and see which one matches. So let's see. Okay, first we have above, which is great, but at 0, it's 0. Well, is that true? It's not. Okay. Let's try the next one. So first we have above, which is great because that's what we wanted, above. Then we have a 0 exactly at the same x value spot, great. Then we have a below, so is this below? Yes, it is. Then we have a 0, there's a 0. Then we have an above. This is a perfect match. Great. And you can try to go through the other multiple choice options and you'll see that it doesn't match above 0, below 0, above. Okay, so look for example here. This is below, well that doesn't match because we want above first. Okay, and so on and so forth. Next one, number 14. The polynomial function f has selected values of its second derivative in the table below. Which of the following statements must be true? So a few things we know. If the second derivative is positive, then we are concave up. Then if the second derivative is negative, we are concave down. Okay? Ready? So those are things that we do know. So let's look at A. F is increasing on the interval 0 to 2. 0 to 2. Is it increasing? 5, 0, negative 7. Well, increasing depends mostly on the information of the first derivative. For increasing, we want the first derivative to be positive. We don't have that information. B. F is decreasing. Decreasing, we want the first derivative to be negative. We don't have that information. F has a local maximum. Local maximum depends on the first derivative as well. First derivative. Okay? We don't have that information. Which we're left with D, which is the graph of F changes concavity in the interval. Meaning it changes concavity, meaning it changes from concave up to concave down. Or concave down to concave up. Well, let's see. 5 is positive, so that means concave up. Negative 7 is negative, so concave down. And then 4 is positive, so concave up. So it does change concavity. Okay? Well, it's focusing on 0 to 2, so we're just looking from 0 to 2 actually. And it does change from concave up to concave down. So that is the answer. Okay, number 20 says, let f be a function with the second derivative given by x squared, x minus 3, x minus 6. This is the second derivative. It says, what are the coordinate points of inflection of the graph? So we need to set the second derivative equal to 0 first. Find the x value. So I have x squared equals 0, x minus 3 equals 0, x minus 6 equals 0, which gives me x equals 0, x equals 3, x equals 6. So now I have to check which of these three are actually inflection points. So I have 0, 3, and 6. So I need to check where the inflection points are by seeing a value before and a value after each point. So let's say before 0, I'm going to choose -1. Between 0 and 3, I'm going to choose 1. Between 3 and 6, I can choose 5. And I have to see whether it's positive or negative. So let's start with -1. So I have -1 squared, -1 minus 3, -1 minus 6. So I plugged it into the second derivative. -1 squared is +1. -1 minus 3 is -4. -1 minus 6 is -7. If I multiplied all of these, I'm going to get a positive answer. Let's do for the same work for 1. 1 minus 3, 1 minus 6. So I have 1 times -2 times -5, so this is positive. So I'm going to pause here and see. Is 0 an inflection point? No, because it stays concave up, and then afterwards it's still concave up. Okay? An inflection point changes concavity. It doesn't. So this is not one of our answers. So let's cross off the answers with 0 in it. Okay, let's try. Okay, so now we're going to focus on 3. So we have to choose a number before and after. We already chose a number before, which is 1. Let's choose 5. Let's see. 5 minus 3, 5 minus 6. So that means 25 times 2 times -1. If I multiply all of this, I'm going to get a negative. So that's a good sign because we change. So we say yes here because we change from concave up to concave down. Lastly, let's choose a number after 6. Let's try 7, okay? So I have 7 squared, 7 minus 3, 7 minus 6. So I have 49, 7 minus 3 is 4, 7 minus 6 is 1. These are all going to be a positive answer. So this is good because that means we change from concave down to concave up. So 3 and 6 are both inflection points. Okay. This is a calculator section. They give you the graph of f prime, which is the derivative. If they give you the graph of the derivative, a few reminders. Above it is positive, so meaning increasing for f. Below it is decreasing for f. Okay, so it's saying what intervals is f increasing? Well, we have to see where it's above the x-axis. So that's from -2, still above, still above, still above, to 3. Okay? So from -2 to 3, I'm above. And from 3 to 5, which is down here, I'm below. Which one here is increasing? -2 to 3 is increasing. So I'm going to choose the answer with -2 to 3. Right here. And you can check the other intervals. It's not going to make sense. -2 to 1 is incomplete. 3 to 5 is we know is decreasing. So that doesn't even answer problem. 0 to 1.5. And 3 to 5. Well, 3 to 5 we know is decreasing. 45 we know it's definitely decreasing. Okay, so when you're answering problems like this, remember to annotate the problem. Write as many information as you can that you know, that you remember. Okay, for 78, the first derivative of the function is defined as f prime of x sine of x to the third minus x for 0 to 2. When is it increasing? So this is a calculator section. We need to graph it. Okay, so I need you to go to your calculators right now and graph the problem.